Swayam Prabha. Digital India. Educated India.
Namaste. We move forward with our summing up and discussion. In module 4, we were looking at the threats to wildlife. And here we were looking at push and pull factors, threats to species, and developmental hazards in ecotoxicology. In the case of push and pull factors, we said that there are certain factors that push species away from them. So, if there are conditions that are not amenable for the survival of a species in a certain region, then the species would not occur in that region. And common examples of these not so suitable conditions are extremes of temperatures, extremes of humidity, things like droughts or floods, or an absence of food, or in excess of predators. So, if there are such push factors, then the species will be not found in those areas. On the other hand, there are certain pull factors that attract a species towards themselves. Things like a good climate, things like abundance of food, abundance of water, absence of predators. So, in such conditions, the species will be found in those areas. And the science that looks at these distributions is known as biogeography, the study of the geographical distribution of life on Earth and the reasons for the patterns one observes on different continents, islands, and oceans. And in this context, we also define range as the distribution of a species or the geographical area within which a species can be found. And then we looked at different Indian habitats from very cold areas to warmer and drier areas, from marine and brackish waters to fresh waters, and very specialized habitats such as the sholas or the mangroves. And if we look at any species, we can find that there are certain specific conditions in which those species are found. So we looked at the example of these coral reefs, which are only found in those areas that have a specific sea surface temperature and do not have muddy waters. That is, there should be clear water and the surface temperature should be warm, and which is why they are only found in these locations. And a similar thing can be looked at for the other species as well. We also looked at altitudinal zonation, which says that even at a location that is near the equator, as you move higher up, the temperatures go down. And when the temperatures go down, you find the same species as are found in those locations that are away from the equator. Now, this tells us that the climate of a region plays the paramount role in deciding what species will be found in those areas. And we looked at the Liebig's law of the minimum, which states that the rate of any biological process is limited by that factor in the least amount relative to the requirement, so that there is a single limiting factor. Which means that whenever we are talking about the distribution of species, there is generally a single limiting factor, which is there in the least amount relative to the requirements. And here we can also talk about the Shelford's law of tolerance, which says that the geographical distribution of a species will be controlled by that environmental factor for which the organism has the narrowest range of tolerance. Now, when the organism has the narrowest range of tolerance, it means that once the conditions are outside of that range of tolerance, then the conditions become so bad that the organisms will not be found in those areas. And we found that these conditions can change. So, when we look at global warming, we are finding that the insects are now reaching into higher areas, because earlier the lower areas were having high temperatures and the upper areas were having colder temperatures. But with global warming, the upper areas are also now having warmer temperatures, because of which now the species are able to reach into those areas. So the mean altitude for malaria has been increasing. Another factor, which is a biological factor, is allelopathy. Now, allelopathy is the condition in which one organism secretes some chemical that inhibits the growth of another organism. A very good example is the antibiotics. So, in the case of antibiotics, certain microorganisms release these antibiotics into the environment to inhibit the growth of other microorganisms. Very good example is penicillin. But together with the antibiotics, we also find allelopathy in the case of, say, deciduous trees, whose leaves, when they fall down on the ground, they also contain certain chemicals that inhibit the growth of other organisms, that is, other plants in that area. And we look that we can experimentally demonstrate whether the inhibition is because of allelopathy. So, in the case of apple tree seedlings in grass, if water moves through grass and into the apple tree seedlings, then the growth is inhibited. But if water moves only through soil and into the apple tree seedlings, then there is no inhibition of growth. And if we just put water, there is no inhibition of growth, which means that there is something that is being released from the grass. It is not there in the soil itself, but it is something that is being released from the grass that is causing an inhibition of the growth of the apple tree seedlings. So, this is a way in which we can experimentally demonstrate that allelopathy is resulting in a certain distribution or range of the organisms. Another factor that governs the distribution and range is predator. Now, if there is an area where you have too many predators, then the prey species will probably not be found in those areas. And in this context, we looked at this example where when the algae uh, growth is looked at in an area from which the sea urchin is removed. Now, in this case, sea urchin is the predator. Once the predator is removed, the algae population bounces back. In certain cases, the prey governs the distribution and abundance of the predator. And a good example is Drosophila pachyia. Now, in this case, the prey is a cactus, and this cactus has certain chemicals, certain sterols that are essential for the growth and reproduction of Drosophila. And so, the Drosophila will be found only in those areas where this particular species of cactus is found. So not only does the predator govern the abundance and distribution of the prey, but in certain cases the prey also governs the abundance and distribution of the predator. And in certain other cases, competition also plays a role. So we looked at this example of interspecific competition, in which one species was pushing everything away from the central portion. So when once it occupies the central portion, it pushes everything away from it. And so interspecific competition can also play a role. And these days, the interspecific competition, because of human beings, is playing the largest role. Because we are displacing a number of organisms from their home places, from their habitats, because we are encroaching upon different habitats. So when human beings think that, okay, this is a forest and we want to have this land, the humans go there, cut the trees, and encroach upon the land. Now, once that happens, the organisms that were already living on that piece of land in that forest, they have to move away. So, interspecific competition also plays a big role in determining the abundance and distribution of organisms. Another thing is behavioral factors, such as habitat selection. Now, in the case of habitat selection, it is just that certain organisms prefer a particular habitat and do not prefer another habitat which would have provided them with adequate amount of food, protection, and other things. So, this is a behavioral thing. It's just a matter of preference. And this preference has innate components and also learned components. That is, some part of this habitat preference comes from birth, and some other part is learned as the organism grows up. So, when it looks at its surroundings, it prefers those areas that it has lived in. Other factors that govern distribution and abundance are dispersal, the movement of individuals away from their place of birth or hatching or seed production into newer habitats. to survive and reproduce. And migration. Migration is regular seasonal movement of animals, often along fixed routes. So, if we do not find an organism in a place, it is also possible that the organism has migrated to some other location. But if it has migrated, then it would mean that it is a regular seasonal movement, which means that if we wait for some more time, probably the organisms will come back with the change of seasons. In the case of dispersal, it is possible that we have a habitat that is very good for a particular species, but it is just that the species has not been able to reach into that area, because of which we are not finding that species in that area. So this also governs the distribution and abundance. We looked at three modes of dispersal. Diffusion is gradual movement over several generations. Jump dispersal is quick movement over large distances. And a good example is the zebra mussel. And the third is secular dispersal, which is very slow in evolutionary time, so that the migrants are divergent from the original population. So essentially, we can have dispersal that is fast, dispersal that is slow, and dispersal that is extremely slow over evolutionary time scales. And the human factor these days is also playing a big role, so that if there is a forest and human beings cut it, then we will not find the trees in this area. And with the trees gone, with the forest gone, a number of other organisms will also be gone from this area. And we can explore what is causing the actual distribution and abundance by looking at transplantation experiments. So in this case, one experiment is to move an organism from one point to another point in its own range. So this is a control experiment, and the control tells us whether we are shifting the organism in a correct manner or not. Because suppose we were shifting the organisms from one place to another, but our method was not good enough and the organisms were dying. So in that case, the control experiment will tell us that our methods are flawed. The other experiment is movement is into other areas, in which case, in certain cases, the transplant will survive, and in certain other cases, the transplant will die. Now, if the transplant survives, then it means that the organism has not been able to occupy that region, either because there is a physical barrier to movement, or the time has been insufficient, or because of behavioral factors. But if the transplant is unsuccessful, it means that the distribution is limited by other species or by physical and chemical factors. So these are the ways in which we can determine what is causing a particular distribution and abundance of organisms. And this becomes important because this distribution and abundance also tells us about the threats. So if there is an organism that is experiencing push factors everywhere and pull factors nowhere, it means that nowhere is this organism finding a place that is good enough for its survival. In that case, the species will be slowly pushed towards extinction. And we saw that quite a large number of species are being pushed towards extinction. So we looked at these threat factors, and these threat factors can be divided into two categories. One is the declining population paradigm, which occurs when the population is moving towards smaller numbers, and the second is the small population paradigm, which occurs when the population is already very small. And different factors act at different scales. So, in the declining population paradigm, we have things like no suitable habitat, competed out, killed out. But in the case of small factor paradigm, we have things like LE effects and the stochastic deaths. So, the chance factors become much more important in the case of smaller populations than in the case of larger populations. And in this context, we looked at the deterministic and stochastic factors. The deterministic factors are things like birth rate, death rate, and population structure, which are acting even at large population sizes. So, if the birth rates are less and the death rates are high, in that case, the population will slowly become smaller and smaller. But then, when the population is already very small, then we have the role of the stochastic factors. So, we have things like demographic stochasticity, environmental variation, catastrophes, genetic processes, deterministic processes, and migration. So, what we see in the case of stochastic factors is that the chance factors are now playing a larger role. And in this context, we saw this acronym HIPPO, which tells us the 5 factors that drive a species towards extinction. It is habitat loss, invasive species, pollution, overpopulation of humans, and overharvesting of the organisms. So these are the 5 most common factors that are driving species towards extinction. Then we also looked at the sensitivity of species to human impacts, which depends on the adaptability and resilience of the species, attention that the humans are giving to that species, the amount of ecological overlap, and the home range requirements. So, if there is a species that is less adaptable, less resilient, the humans are paying a lot of attention to that species, probably because it is a beautiful or a majestic species, and so humans want to kill it and put it in their homes. If there is an ecological overlap, which means that the species is found in those areas where the humans also want to occupy, things like plain areas. And if the species has larger home range requirements, so in that case, the species is much more susceptible to the impacts of humans. Then we looked at this formula from the island biogeography model that the species richness is given by C, which is a constant, into the area of the or the size of the island to the power of Z, which is another constant. And with that, we looked at the rate of species loss, and we estimated that around 27,000 species are being lost every year. So when we say that we are losing out the species at a very fast rate, then it is not just a theoretical thing. We can actually derive this value from the models. And in this case, we saw that all the species are not equally susceptible to extinction. If a species is rarer, then there is a greater chance of it getting extinct. And a species is rarer because of things like habitat selection, evolutionary characteristics. So if there is a species that is found only in desert springs, so because the deserts are less in number, the springs in the deserts are less in number, so these the species will also be less in number. Or if there is a species that has a limited geographical range, such as the species found in a single lake which cannot fly away, or the in the case of certain species that require more space, in that case they already have a low population density. Animals such as elephants or tigers, they do not produce a very large number of offsprings with each birth, and so in these cases the species will be rarer. And we looked at 4 different things: habitat degradation, fragmentation, displacement, and loss. Now, habitat degradation is the process by which the habitat quality for a given species gets diminished. So, when we say degradation, the quality is going down. Why does the quality go down? Probably because there are pollutants, probably because people are cutting away trees, probably because there are certain insects that have infested into this area, diseases, forest fires. So, we have n number of factors because of which there can be habitat degradation. Contamination such as air pollution, water pollution, eutrophication, pesticides, trash such as ghost nets and plastics, soil erosion, fire regimes, so water overexploitation, deforestation. We looked at several examples through which habitat gets degraded. Desertification, which is often caused by overgrazing and cultivation practices, overexploitation of species or biota, which means that the humans are extracting away these species at a rate that is faster than the natural rate at which the population can restate itself. That is, if we are removing species at a rate that is greater than the birth rate minus death rate, in that case, we will be pushing the species towards smaller values. Introduction of exotic species. So, there are several factors for habitat degradation. When habitat degradation reaches an extreme, such that the quality of the habitat is now so low that the habitat is no longer usable by a given species, then we say that it is a situation of habitat loss. So once you have a habitat loss, then you will no longer have any organisms of this species that are living in this area. Another thing is habitat fragmentation. Habitat fragmentation is when a natural landscape is broken up into smaller parcels. Now, this is important because the larger fragments often have more diverse environments and so support more number of habitats. The larger fragments will have larger number of species, both common and uncommon species, and they will have a lesser chance of getting extinct because the stochastic factors will not be that important, which is why we always prefer to have larger areas. But in the case of habitat fragmentation, what happens is that in place of this big habitat, if there is a road here, say a pipeline here, or say a canal here, in that case, we have such smaller pieces of habitat that are left. And because there is this road that is passing, so the organisms from one portion will not be able to move to the other portion. And in that case, we will have several smaller habitats, and so the species that have larger home range requirements, they will get extinct. Species that require movement from one place to another place because of things like migration, they will start getting extinct. And also, the chance factors will start to play a much greater role. And some causal agents for habitat fragmentation include things like linear infrastructure or diversion of land for agriculture. And in this context, we looked at the process of habitat fragmentation and loss. So, from a pristine forest, when we have a road, the road causes a dissection in the habitat. And once there is dissection, people now have access, and so a perforation starts. People start getting in, animals start getting in, the livestock numbers grow. Once you have humans and once you have the animals, then slowly and steadily they set up small shops along these roads, and slowly the population also starts to increase. So once the human population increases, now the fragmentation begins at a faster rate because now more and more land is required for agriculture, more and more land is required for pasturing. And then bigger buildings come up in the area, and slowly and steadily we have attrition. So in the phase of attrition, now the habitats have become so small that now only very small pockets of the original habitat are left, and the other areas are already now filled up by the humans. So this is attrition. And we looked at this example in which only this small patch of forest is remaining on this hill. And we saw this example from the Amazon rainforest that slowly and steadily this forest gets converted into this stage. That is, all the forest is gone. This is a completely attrited habitat. And in this context, we also looked at habitat displacement, which is shifting of wildlife to non-prime or subprime habitats, such as hilly or rocky patches. So what happens in this case is that the prime habitats are taken up by human beings for their own living, for agriculture, or for the grazing of animals. And so the original inhabitants of the area, the original biodiversity has got no other option than to shift to non-prime habitats, which probably will not be having sufficient amount of food, sufficient water, or sufficient protection. And in that case, we will be slowly pushing those species towards extinction because now they are facing the push factors. Then we saw that we can make use of population viability analysis to analyze these situations. We also looked at developmental hazard, and in this context, we saw that there is a difference between growth, which is an increase in size or the level of output, and development, which is the process by which the economic well-being and quality of life of a nation, region, or local community are improved according to targeted goals and objectives. But the issue is that in a number of cases, when we say that we want to develop, we are developing, we are only looking at growth, we are not looking at the other factors. We are not looking at things like equality, we are not looking at things like education, and in that case, we are just going for a growth without development. And we saw that if we make this curve between production and empowerment, then again, there is a production possibility frontier. So you can choose between different values of production and empowerment, but you cannot have all the production or all the empowerment at the same time. So again, the society needs to choose. And in this case, if we only have an increase in production without an increase in empowerment, then we will say that this is economic growth. If we have only an increase in empowerment, that is also possible. But once we have growth together with an increase in empowerment, then we will say that actually development is happening. But if we are not doing a sustainable growth, if we are not targeting development, which means increase in the living standards, in that case, we can have an unsustainable growth with several tragic consequences like these. So, this is what we are focusing on these days. And in this context, we saw that our coral reefs are now getting bleached, the mangroves are going down, the ice sheets are melting, the animals are dying after eating plastics. So, several things are happening, things like fragmentation, pollution, deaths of animals on the roads. So, we saw all these different aspects of unsustainable growth. And we also looked at ecotoxicology, which is the study of the effect of toxic chemicals on biological organisms, especially at population, community, ecosystem, and biosphere levels. Now, in this context, it is important to remember that whenever we release any toxins into the environment, slowly and steadily, we will also get exposed to those toxins. Because man is also an animal, and there is no way that we will be left out from the negative impacts of what we are doing to the environment. And so, when we talk about economic growth versus development, then good health is a component of economic development. Now, in our rush for economic growth, if we release so much amount of pollutants that people became unhealthy, people became sick, then we will not call that a development. That will be only an unsustainable growth, which is what in a number of cases we are targeting these days. And so we need to be mindful that whenever there is a release of toxins, then we will find that slowly and steadily these toxins will also reach to us through movement through the food chains. And in this context, it is important to talk about the biomagnification. Now, biomagnification is the process in which these toxins get accumulated in the body through the process of bioaccumulation, and as we move up the food chain, the concentration of these toxins goes on increasing because each predator is eating several different prey, and each of those prey is probably a predator in its own accord, and so that is also feeding on a number of other organisms. And so what is happening is that all the toxin that was there in all the prey combined, that reaches into the body of one predator. What we are saying here is that if there is this species and it is eating this, so many animals are being eaten by this species. So then the suppose the concentration of toxin here was alpha, the concentration here will become beta, which is very much greater than alpha. Now, if these species are being eaten by this species, so several individuals of this predator are eaten by this one, and here we will have a concentration of toxins which is gamma, which is very much greater than beta. And in a number of cases, when we have a very small concentration of toxins, then probably the organisms will be able to survive. There will not be a very large negative impact. But when the concentrations increase through biomagnification, we start observing things like this. That in the case of bald eagle, which is the national bird of the United States, we found that as the DDT concentration went up, and the amount of DDE residues in the eggs, it went to such a large extent that the eggshell thickness reduced, and which led to a plummeting of the population. Now, the good thing is that in a number of cases, the populations are resilient, which means that we still have a chance. If we uh, stop releasing these toxins, then there is still a scope that these populations will come back to the original levels. And in this case, we talked about restoration, which aids the recovery. And we also looked at methods such as phytoremediation, which can be used to reduce the amount of toxins that are there in the environment. We began by the fifth module by saying that because conservation and economics are so related to each other, because there are so many bad economic decisions that are leading to environmental problems, but also because economics is what decides about the priorities and about the funds that will be allocated to different things. So we need to understand how an economist thinks so that conservation can also be achieved. And so in the fifth module, we looked at the need to understand the controls, thinking like an economist, and the interdependence and gains from trade. And we began with this hypothetical example that if there are two pilots in a plane and they are looking at different dials, they are not looking at the same dials. And the first one thinks that okay, things are going very fine, and the second one is getting hysterical that things are not going that fine. Now, mind you, both of them are reading the dials correctly. It's just that they are reading different dials. A very similar situation is occurring today when we talk about topics such as conservation and economics. Because the conservationists might say that okay, so many species are dying every year, and so we are in a very bad phase of our existence. On the other hand, the economists might say that no, the GDP has been growing, more people are getting jobs, we are shifting from primary to secondary and tertiary and quaternary sectors of economy, so things are going very fine. Now, the thing is, both are correct in their own ways because while we have been growing economically, we are also causing a lot of disasters. So it becomes extremely crucial that both the economist and the conservationist come to the same talking terms. They understand each other. And so in this course, we have emphasized that we need to understand what the conservationists say, and we also need to understand what the economists say and think. And only when we understand both of these will we be able to bring out a correlation between both of these. And so in this case, we say that is it okay to read certain readings and ignore the rest? That is, when the economist is saying that things are not uh, that bad, things are actually going good, they are ignoring away the readings of conservation, the readings about the species that are dying, the readings about the habitats that are getting destroyed. On the other hand, when the conservationist says that no, things are very bad, in that case, they are also disregarding the readings of the economists. That actually the society has been developing, the society has been growing, and we are now having access to much more things than our forefathers did. And so we need to find out a middle way in which the society can reap the benefits and also we can protect our environment because ultimately we are protecting the environment only for the benefit of the society. We are protecting the environment because it gives us certain benefits in the form of clean air, clean water, and the ecosystem services. If we did not have those, we would have to spend money to gain those facilities, such as through installation of air purifiers or water purifiers or dams. And in that case, when we devote money into cleaning air and cleaning water, then we will have less money left for the welfare of the society. And so, here again, this is just an economic decision that needs to be made, but an economic decision that also takes into account what the conservationists are saying. And so, in this case, we talked about sustainability versus utility. And sustainable development is the development that lasts, the development that meets the needs of the present without compromising the ability of the future generation to meet their own needs. That is sustainable development, something that lasts for a very long period of time. On the other hand, utility is a measure of happiness or satisfaction. And in this context, we have the philosophy of utilitarianism, according to which the government should choose policies that maximize the total utility of everyone in the society. That is happiness of the society. But the thing is, if we do not do the computations rigorously, if we do not make rational decisions, then it is possible that in the quest for increasing the utility, we may actually diminish the utility. Because remember that utility is happiness or welfare of people. And we cannot say that people are healthy, are happy, and they are having welfare if they are not healthy. So, if the environment is polluted, if people are sick, if people are not getting um, clean air, clean water, clean food, sufficient quantities of food, if they are not getting sufficient entertainment, if their soils are running bare, the productivity is going down because of environmental disasters, in that case, we cannot say that people are having happiness or welfare. So, in this case, when we talk about utilitarianism, we need to expand the scope. It's not just the material things that matter, but also a well functioning environment that is necessary for the happiness of people. And so we need to bring both of these together. Currently, the differences between the economic and the ecological thought process are things like the time horizon, small versus large. In the case of an economic thought process, we are only looking at the short periods of time. We are only concerned about what is happening the next month, probably the next month, the next year, or probably in the current decade. We are not taking a longer time horizon. In the case of an evolution of an ecologist time horizon, they look at things like this century or the next century even. We need to understand the difference between sustainability and utility, and there is also a need for internalization of the externalities. Now, internalization of externalities is something that we will come again and again throughout this course. It means that if I am doing something that is giving me a benefit but is also causing a harm to others, and if I discount the harm that it is causing to the others, then my decision will not be rational. And if we internalize the externalities, we will have a situation of economic development, and at the same time, we will be conserving the environment as well. And in this case, we looked at the externalities, the negative and the positive externalities, and the methods of internalization of externalities. Things such as regulation in a command and control policy. So the government might say that, okay, such and such things are causing negative externalities, so they will not be permitted. Or we can have market based policies such as Pigouvian taxes and subsidies, which are taxes and subsidies that are uh, imposed or implemented only to alter the behavior of people. They are not for increasing the revenue of the government. Or we can look at things like tradable pollution permits, which again bring us to the same market based mechanisms and bring us to the same uh, final result. Or we can look at private solutions, social norms and modes, charities, integrating businesses, and the Coase theorem. And one of the most important things here is the Coase theorem, which states that if the private parties can bargain without cost over the allocation of resources, then they can solve the problem of externalities on their own. And we looked at this example of the gypsy drivers, and if they are able to bargain, then we can have a situation in which both the parties are able to benefit. And Coase theorem is very important when we talk about the externalities, especially things like pollution. Now, if there is an industry that is causing pollution, and if the government ensures that the parties, that is the industry and the society, are able to negotiate, bargain with each other without a transaction cost, in that case, they will come up with a solution that will reduce the pollution, or at least pay back to the society so that they are able to live with the pollution. And when the industry is made to pay others, then automatically there will be an incentive to the industry to reduce the pollution so that it does not have to pay to the society. That is, we have mechanisms through which we can ensure conservation, we can ensure that pollution levels go down. The thing is, we need to implement them rigorously. And in this context, we also looked at the kinds of goods that both look at. So we have private goods, club goods, common resources, and public goods. And today, in the case of economics, we are mostly concerned with private goods. Whereas in the case of ecology, we are looking at things like club goods, common resources, and the public goods. Now, the thing is, all of these goods are economic goods. And so, when we are doing an economic decision making, we need to incorporate our knowledge and our learnings about these goods as well. Only then will we be able to reach the most efficient solution. And in this context, we also looked at linear infrastructures as an example of how we can change our thought processes. Now, linear infrastructures such as roads are creating havoc for the wild animals because quite a number of times the wild animals come to the road, they get hit by the vehicles and they die. Roads also lead to a heavy amount of habitat fragmentation. But the thing is, if the ecologist only highlights that the roads are bad for our country, then that is not going to help because the roads also play a very important role in bringing people together, in ensuring that things move from point A to point B in the most efficient manner and in the shortest possible time. So, if the ecologist just goes on saying that no, 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 roads are bad for us, then that will not solve the problem. But if the ecologist understands why roads are necessary, then probably he can come up with a thought process that will help the animals as well. So in this case, the ecologist might try to highlight the fact that when the wild animals come to the road, it is not just the wild animals that get impacted, but also the people. Whenever there is an accident, we have a loss of property in the form of the vehicle, but we also have injury to people, we also have loss of life of people. Now, if you wanted to ensure that the wild animals do not come to the road, then there are again two options. You can build very great sized walls that would prevent the animals to get from getting to the roads. But there is also a cheaper alternative. Just just demarcate some areas that are wild animal crossings. And once you do that, the animals will cross from there, and in that case, the human lives will be saved. Accidents will not happen. Currently, when we are not putting animal passageways, what we are doing is that we are forcing people to move at slower speeds. In a large number of our wildlife habitats, the speed limits are just 20 kilometers per hour. And when we have such low speed limits, then we can not have the development of the country because it is not good for economic growth or development that our people should be moving at such slow speeds. But if we had the animal passageways, the people would be able to move at a much faster speed. And probably once we take into consideration that yes, we need to ensure that the speeds are good, the animals are protected, the habitats are protected, then probably we will start thinking of options such as over bridges. And in that case, the speeds will go up even further because in place of taking a winding road through the forest, we can even go for straight roads. And so there are options available. It's just a point to modify our thinking to incorporate to all the information. And that's exactly what rational thinking also demands. That you take all the information, you process the information so that you can maximize the welfare of the people. And so in this case, we saw that yes, animals get on the roads and animals die. There is pollution and there is fragmentation. There is destruction of habitats. But then there is also accidents. Roads are changing the behavior of animals, but then uh, roads are also ensuring that we move at a slower speed because the animals at times also create issues for humans. And so we have these slow speed limits, just 20 kilometers per hour. Now, if we shift it to underpasses or overpasses, then we will be able to reach to a situation where the economic development goes even further. Then in the next lecture, we looked at thinking as an economist. That is, to understand economics, we need to know the terms of the trade, the methods that are used, the analysis that are done, and the field realities. And we looked at several different terms throughout this course. So, in this course, we have emphasized that yes, to understand economics, we need to understand the terms, the meanings of and definitions of all these different terms. And we need to understand the scientific process, the scientific method, in which there are observations that lead to questions. When you have a question, you form a hypothesis about what can be the reason why a certain thing is happening in a certain manner. That is the hypothesis. Now, once you have a hypothesis, the hypothesis can be proved or disproved using experiments or observations. Now, if a hypothesis gets rejected, then we move to another hypothesis. If the hypothesis gets proved, then we say that okay, this is the reason why a certain thing is happening in a certain manner. And once we have a confirmed hypothesis, we call it a theory. And if the theory stands the test of time, then it also becomes the law. Now, this is the scientific method, and the scientific method is something that is common between the ecologist and the economist. Now, both being scientific disciplines are emphasizing on the scientific method to understand the world around us. So the economist also does experiments, the ecologist also does experiments. The economist also makes observations, hypotheses, proving and disproving. The economist also makes the same thing. But the thing is, we need to understand and appreciate that both these disciplines are using the same methods. And if they are using the same methods, there is always a possibility for both of them to communicate with each other. It's not that these are two different silos that cannot talk to each other. We looked at several examples, and in the case of economics, we often make use of natural experiments such as wars, famines, diseases, etc. Because whenever we talk about an experiment, in the case of economics, it will also have human repercussions. So, to avoid human repercussions, we make use of natural experiments, things that have already happened, and the data that we can get from them. And because doing experimentation is not that feasible, so we make use of assumptions and models. And model is a simplified depiction of the reality. So it is a simplified description, especially a mathematical one, of a system or process to assist calculations and predictions. And in economics, we make a heavy use of models. And whenever we are using a model, we are making certain assumptions to simplify things. So assumptions such as people are rational thinkers. People take decisions taking into account all the information, processing all the information to choose things that provide the greatest benefits to them. Now, this is an assumption, and we have observed in some of the later lectures that at all times these assumptions do not work. But then we make use of these assumptions to simplify things to understand how the economy works. And in this case, we looked at a few models. One is the circular flow diagram, which states that the firms and the households interact in two markets. One is the market for goods and services, and the second is the market for the factors of production. And in this course, we looked at both of these markets. We tried to understand how the firms make a decision about what to produce, how much to produce, when to produce, how to cut costs, how to decide how many number of people need to be employed, and so on, so that they are producing the goods. Now, in the process of producing the goods, they are also hiring people, they are hiring capital, they are hiring the land from the households. Now, in the case of the market for goods and services, the firms do the selling of goods and services, and the households do the buying of these goods and services. And in this way, the money moves from the households to the firms. In the case of the markets for the factors of production, the households sell the factors of production, that is land, labor, and capital. And the firms buy these factors of production. And in this case, money moves from the firms to the households. So there are these two different markets that are always working in an economy. And because the money moves from households to the firms in one market and from the firms to the households in the second market, so money always keeps on circulating, and which keeps the economy in motion. Another thing that we looked at is the production possibility frontier. Now, this is again another model in which we say that if there is a society that is making only two goods. Now, remember that there is no economy that makes only two goods. This is a simplification, but we make this simplification to understand how the economy is working. So we make the first assumption is that there are only two goods. The second assumption is that the factors of production for good one and the factors of production for good two are one and the same. That is, you can use the land, labor, and capital to produce either good one or good two. Whereas in a number of cases, this might not be exactly correct because the kinds of requirements that you have to say make a computer is very different from the kinds of requirements that you have to make bread. But then this is again another assumption. Now, with these assumptions and simplifications, we ask the question, what can the economy produce? And so we came to the conclusion that the economy can choose to produce only one good, or only the second good, or both of the goods. And if we look at what all goods can be produced, we can come up with this line, which is the production possibility frontier. It means that any point that is outside of this is a point that is an impossible combination because the society will not have enough resources to make that number of good one and good two. The other option with the society is to have these points, which are within the production possibility frontiers. Now, these points are possible. It is possible to make the goods, but then these are not efficient because the society could have both the goods, but then it is producing less of both the goods. Now, with this, we can understand several uh, things about the working of the economy, about things such as the marginal rate of substitution. So, when if you look at these two straight lines, which are the slopes of the curve at these 2 points, or say the slope of the curve at this point. Now, what is happening is at this point, the society is producing 3,000 computers but no cars. Now, if the society reduces the number of computers by a little, it will be able to produce a very large number of cars. So, if the society moves from this point to this point, the number of cars has increased by a very large amount, but the number of computers has gone down by very little. And similarly is the case of movement from here to say this point. Now, at this point, the number of cars has reduced by only this much, but the number of computers has increased by a lot. Now, if we understand these things, we can understand concepts such as the law of diminishing marginal product. So, what is happening is that when you are making too much of something, then your factors of production are not working that hard. You do not get those results that you would be expecting when you were producing something in a smaller quantity. So, when you are diverting some people and some resources from computers into cars, then the productivity is very high. Whereas when you are diverting resources from very large number of computers to a little large number of computers, then the the productivity of the people is not that high. And so there is a very small change in the number of computers that will be produced here. And so the models help us understand how the economy works. So here we can also highlight the fact of the opportunity cost. If the society wants more computers, it will get less cars. We can understand things such as the growth in the economy. So if there is a technology that can increase the number of computers that can be produced, so in that case, now the society can shift from this point to this point where it can have more computers and more cars. And we also looked at these two levels of analysis, microeconomics and macroeconomics. Microeconomics is the study of how households and firms make decisions and how they interact in the markets. And macroeconomics is the study of economy wide phenomena, that is, how the economy works as a whole. Then we looked at interdependence and gains from trade. And in this case, we said that if there are two people, now here again this is a simplification, but if there are only two people and each person can make only one thing, then there is no other option than to trade. But if there are two people and they have different absolute advantages, which means that one is very good in producing milk and the second one is very good at producing potatoes, then too, for the economy, it is easy to understand that if the person who is very good at producing milk produces only milk, and the person who is very good at producing potatoes produces only potatoes, then the society will have more milk and more potatoes. and so they should trade. That is, if the milk producer wants to have potatoes, he should give some milk to the potato grower and get some potatoes. Similarly, with the potato grower. But the thing is, if there are two people and both are making both the goods, and one has an absolute advantage over both the goods, then should they trade or not? And in this case, we came to the conclusion that even then they should be trading. Because what happens is that when there is a person who has an absolute advantage in making both the goods, even then that person will be having a comparative advantage in only one good. And if there is a difference in the comparative advantage between two people, then the people should be only making those things that they have a greater comparative advantage in. And we looked at the example of a surgeon who is also a very good typist. But then the amount of comparative advantage that the surgeon has in doing surgery is much greater than the amount of comparative advantage he would have in doing typing. And so, even though he is a very good typist, he should always hire a typist. So, we saw that through trade, uh, these two parties can have both more of both the goods, and so trade is inevitable. And a lot of this trade happens in markets. And in the markets, we looked at the definition of a market, a group of buyers and sellers of a particular good or service. Now, markets may be organized or unorganized, and they may be competitive or uncompetitive. And in the market, we have the demand curve and the law of demand. The demand curve is always sloping downwards, and the law of demand says that if the price goes down, so if you move from this point to this point, when the price goes down, the quantity demanded increases. And we looked at the movement in the demand curves. If there is an increase in demand, then the curve shifts to the right. If there is a decrease in demand, the curve shifts to the left. And similarly, we also have a supply curve. Now, this is a supply curve. So this is a supply curve. And the law of supply states that when the price increases, so when we move from this point to this point, so when price increases, more is the quantity that is supplied in the market. And if there is an increase in the supply, the curve shifts right. If there is a decrease, the curve shifts left. And both of these curves intersect at a point that gives us the market equilibrium. And at this point, we can find out the equilibrium price, which is given by this point, and we can find out the equilibrium quantity, which is given by this point. So this is the market equilibrium. So when we have the given demand curves and the supply curves, this is the equilibrium quantity that will be demanded and supplied, and these will be demanded and supplied at this particular price. Then we looked at certain cases that if only the demand increases, then we can understand that by moving the demand curve to the right. And in this case, the quantity demanded increases, the price increases. If there is a decreased supply, then also the price increases, but the quantity demanded reduces. And we saw that if there are both increased demand and decreased supplies, then the price will increase, but the quantity demanded or supplied may either increase or decrease, depending on the elasticity. And with elasticity, we mean what is the slope of these curves. So when we say that the demand curve is sloping downwards, is it sloping downwards at a fast rate or is it sloping downward at a slow rate? Similarly, when we say that the supply curves are sloping upwards, are they sloping upwards at a fast rate or at a slow rate? Now, in this case, we talked about elastic and inelastic demands and supplies, and we can remember it by saying that inelastic, because it starts with the letter I, so it should look like the letter I. So when we write inelastic, the inelastic curves will look very vertical, whereas the elastic curves will look more horizontal. And in this case, we saw that if there is a bumper harvest, then because the demand for food grains is inelastic, so it will lead to a lower revenue for the farmers. So it is a bad news for the farmers. So things such as elasticity can help us understand certain economic decisions. Now, elasticity plays a very important role in deciding the share of burden between two parties. Now, if the curves are inelastic, the party will suffer more. And we saw that even in the case of taxation, the amount of deadweight loss is given by the elasticity of the curves. So, elasticity is a very important uh, theoretical construct. And we also looked at government policy. In many cases, the market does not lead to the most desirable outcomes because may be cases of discrimination, there may be cases of exploitation, there may be cases of externalities. And in such cases, the government is required to alter the market outcome by things such as price floors or price ceilings or taxes or subsidies and so on. So, in this lecture, we explored the impacts of price ceilings and price floors, and we also looked at things like the cost of taxation. So, if there is a tax, then the tax gets distributed between the buyers and the sellers depending on who has the more inelastic curve. And there is also a deadweight loss that is involved in the case of taxation. So the government may alter the market outcomes, but it should do it with certain amount of precaution. So that's all for today. Thank you for your attention. Jai Hind.